Hello, everyone, and welcome to Handmade Hero, the show. I forgot about the fact that that would just be looking straight back at us there from the pre-stream. Um, Welcome to Handmade Hero, the show where we code a complete game live on stream, on Twitch. No engines, no libraries, it's just us. And we do all of the code for the game, not just the little bitty tippy top at but the whole thing. And right now we're in the middle of doing something that I want to do for a while, but everything in due course. You can't rush things. And so it's kind of come to the point where now we can finally do it. And that is to get ourselves off of bitmaps and wave files and switch over to a proper asset file system that we can sort of use. And when I say file system, I don't mean a file system like FAT32. I mean an asset file, which, a system for using the asset file where we can load all of our resources for the game out of it, all of our assets for the game out of it, and it defines all of the things that we need to know about those resources in order to run the game. And so we started on that yesterday, and now today I think we probably will get a chance to go ahead and actually write out an asset file. And I don't know whether we'll get a chance to read it in as well, but I think between today and tomorrow we should be in a good shape to kind of have everything, roughly spec'd and working. So let's dive right in there. Today is day 148. So if you would like to follow along at home, you should unpack day 147's source code into the directory where you're going to be working if you would like to follow along with us. And remember, be a programmer, not a faux grammar. All right, we'll just put that away. Okay, so where were we? Let's get back to where we were. Here we go. What I did, and you remember yesterday I did a little bit of, I simplified the asset system a bit. We had added some unnecessary complexity in there, and I removed it when I saw it, so that was a good thing, but it took up some time yesterday. But this is where we're at the moment. All these things are loading in off of disk as individual files and that sort of stuff. Uh-oh. That's no good. Looks like the simplification I did yesterday has some kind of a problem with it, potentially. I thought we tested this. But it looks like... this is going... This doesn't look like that's related, actually. This looks like we have a bug in our estimation of when the sound is going to stop, right? Because look at this. Playing sound samples played is one entire buffer over, right? 47,800, and it's only 48. That's interesting. We should probably... I'm sorry, it's actually under. That's what I meant to say, sorry. So it didn't quite end where it was supposed to end. So input samples were supposed to have ended, but it didn't actually go there. And this was something that we had taken a look at earlier. So we should probably debug this before we take a look at the asset thing, because if it's a transient kind of error here, we don't really know, we want to make sure that we understand what it actually is, rather than just assuming that it'll happen again later at a convenient time because we don't know that it will. So let's take a look at what happened here. What did we actually see occur? We looked at chunks to mix and chunks remaining in sound, and they were actually going to be disparate. Now I assume that they aren't anymore because chunks to mix actually got modified. Let's see if that's actually the case. Yeah, chunks remaining in sound. So what's interesting about that is even at this point, these things should have been equal, right? These things should have been equal, and they're not. So where does that actually get updated? We got to sort of page this back into our brain here. But chunks to mix doesn't get touched anywhere, right? Like if you look at what happens here, we come in here, we say chunks to mix if it's greater than chunks remaining in sound, right? And that's the only way input samples ended could have been set to true. So we're assuming that this actually happened, right? Because otherwise input samples ended would not be set to true, and we would not be able to end up in this part of the code, right? So in order for that to have been set to true, it means that chunks to mix and chunks remaining in sound would have had to have been equal here. So the only way that I could think of that what would have happened... Oh! It's the volume. So we must have had a volume change. Ah! Yeah, you can see the bug, right, guys? Do you see the bug? This is kind of an interesting kind of bug, and I feel like this sort of, this begs the description here, where I should talk about this kind of a bug and point out a good way that we should probably try to avoid it, I would say, if we can. I don't know if we can or not. So, here's what I would say about this. Why did this bug happen? And first I'll say what the bug is for people who don't already know what the bug is. You know what, and let me also move it over to the side where my head isn't so we have more room. All right, so if you take a look at what happened here, when we do our audio mixing, we wanted to know how far we should mix in the sound. And we do that by looking at how much we could mix, how much we want to mix, see if we would run out of samples. If we would have run out of samples, we set, we sort of truncate the amount we're going to mix. We also look at the volume change, and if the volume changes we're gonna end, we also have that as a stopping criteria, right? And then what we do is we just let this thing loop as many times as it needs to finish the various sort of sections, different sections that it needs to go through, and all that sort of stuff, right? Well, the bug is when we figure out if the sound was going to end, right? We say that input samples ended equals true, and we set the chunks to mix to be how much it would take to get to that point. But we then go ahead and potentially stop earlier than that when the volume change would have ended, which means that at that point, input samples ended will not necessarily be true, right? And so the problem that we have here is we're recording this match and assuming that it's going to stay true, even though we have other things that might cause it to not actually be true. We had this bug for both volumes ending at the same time. We even put a to-do here for it. It's the same bug. Now we have 3 different ways in which this could happen. 3 different things where we don't know exactly when they're going to end. And so that's kind of, that's kind of just underscoring why this sort of structural way that we've chosen to trigger this stuff here is maybe not a good idea, because we've already seen basically 2 different types of bugs, or 2 different bugs that can arise from the exact same thing, right? So the question is, could we come up with a better way, right? And I think that the better way here would probably be to say, well, if we have chunks remaining in sound, and we know that we're setting chunks to mix to be equal to that, right? Since we're not modifying either of those 2 things, we're not modifying the chunks remaining in sound. When we do chunks to mix and that kind of pulls through here, right? What we could do is instead of testing input samples ended, we could just say if these 2 things are equal at the end, then we know that it actually ended, right? We could just make that be the definition of input samples ended, right? If those 2 things were equal. And I think we kind of did that before, and we had reasons why we didn't necessarily want to do it because of the way that we were actually processing the loop. We were using the sample position, I guess, actually was what it was. And that was a little bit touchy because that thing was getting updated in various ways. Since we know that chunks to mix is a fixed amount and we will advance by exactly that amount through the loop, it feels like this might be the smarter way to do it, right? And so then volume ended would be pretty much exactly the same thing. Instead what we would do is volume ends at, or something like that, would be what we would record. And then so instead of saying volume ended, instead of doing this, right, we would just do this. We would say, oh, okay, this was the actual value that we set chunks to mix to. So if at the end chunks to mix is still equal to that, then we know that that particular volume ended, right? Does that make sense? So really what I'm doing here is I'm saying, let's make the criteria that we actually care about, let's make that be the thing that actually gets used, right? And I feel like that should be a little bit better, right? I feel like that should be more in line with what we wanted, if that makes sense. Let's see here. So let's go ahead and make this operate over that array, and this one as well. Oops, that's no good. Volume ends at. And let's see if that's a little bit clearer. Yeah. So I'm a little more comfortable with that. And really what that's doing is that's just saying, well, if we've got these things that are actually dependent on a particular variable, instead of introducing these secondary variables where we might make a mistake in how they set their state, because that state is really not representing the actual end condition, can we go ahead and bake it down so that it's actually checking the real condition, which is this chunks to mix. That is the thing that we, as we go through this code, right, chunks to mix is the thing that we're actually updating to represent how far we actually need to go. So if that's the primal piece of data, having the end conditions operate on that primal piece of data means that as long as the algorithm is working, our end check will work. Whereas the other way, there are these ancillary values which have nothing to do with how the algorithm actually functioned that we were just setting. Those can easily become out of sync with the algorithm, or we can misunderstand how they might be set or forget one of the things. And so it really does help, if you can, to try and condense code that way so that it's actually working with the specific conditions that are actually important, and not have it be about sort of these separate things that you're sort of setting. And so I think this will be an easier routine for us to debug now that we've gotten rid of that additional state. So that's good. I'm glad we caught that. That's pretty cool. And you'll also notice another point there, just while we're talking about debugging things. You'll notice that probably we never would have known about that bug. We would have just had maybe a little audio error, because all that would have happened is our sound would have stopped soon. So the only reason we even knew that that happened is because we placed this assert in here to check. And so again, that's why if you're not used to using asserts, again, I'm not the kind of person who tells you to stick a lot of stuff in the code that's extraneous, right? I'm very sparing that way. But you'll notice I do often stick asserts in there, and I actually stick less asserts in this code when I'm on stream because we have a limited amount of time, and I don't always have the ability to kind of relax as much as I would like to into the programming and think about it, because I have to talk and all those sorts of things. So I even put in less probably than I would in my normal code. Assert is something I really do recommend. It is not one of those things like const where I find that it's just kind of a waste of typing and it doesn't really catch bugs. Asserts catch bugs, and they catch the kind of bugs you care about catching. They catch bugs like this where we never would have caught, we never would have even known about that. It just, there would have been a little audio scratch at the end of sound sometimes, or something may have gotten truncated in just the right way one time, and you'd be like, what was that? And it's like these little hard to find bugs. That is exactly what assert does for you. And so I really would like to, every time it happens, I try to point it out, where it's like, that is a bug that would have been really hard to ever find if you hadn't put an assert in there. So asserts, they are your friend. And and they're a good tool too, because you can fine tune them to catch the kind of errors you make. As you see yourself making, the more you code, the more you'll know the kinds of bugs you will make. And it's not the same for everybody. I mean, there's some kind of bugs that everyone has, so it's just complicated, whatever. But there's other types of bugs, and const is that way too, right? Like, I don't necessarily know that other people might not actually catch a lot of bugs with const. I catch no bugs with const, so I don't type it really. But assert is kind of flexible in that way, right? You can choose to put in the asserts that catch the kinds of bugs that you find yourself making, right? And so as you get a little bit more familiar, if you're a newer programmer, as you get more familiar with the kind of mistakes you make in whatever the language is that you happen to be using, and the type of code that you have to be writing, it's a good idea to get familiar with that and learn to place the proper asserts to safeguard yourself against the mistakes that you tend to make. You can think of it kind of like, like a rock climber places bolts and as they go up the ascent to prevent themselves from falling. That's very much the way you kind of want to think about asserts. It's like, know yourself, know how you tend to screw up, and let the asserts be a way that you can guard against the mistakes that you're going to make, because every programmer, I don't care how experienced they are, how good they are, will make mistakes. And a lot of being effective at programming is knowing what they might be and how to catch them and recover from them quickly, right? So again, can't stress that enough. It's a very good thing to learn how to do. And that was an example of a very helpful assert that caught a bug that, you know, may have just shipped in the game for all we know. Like that could have totally gone out, right? And we always would have had a little glitch in there. So yeah, so that's cool. That's a good thing. And let's now go back to what we were doing, which is we wanted to make our handmade asset processor, right? Basically a little test piece of code. It's called test asset builder. And we were in the process of getting this working. So what we wanted to do, if you remember from yesterday, is right now in the game, we basically just faux build a bunch of assets in the middle of the game. Like we just say, okay, at startup, we're just like, build a fake asset structure like that has a bunch of assets in it that we want, and just use file names to say where to go grab those assets off of the actual directory structure on disk when you need them, right? And so that's how we were doing things. What we want to transition to is a single big file that we can just open a single handle to, seek around in it as necessary, and grab the assets out. And the file itself will contain all the information we need to quickly grab things and all of the metadata we need, so that all of this stuff that we're currently having to annotate in here inside the game all just goes into the file and can be produced offline. So to facilitate this process, and again, what I'll do is I'll actually make that asset file for us, taking all of the art that Yangshan did and putting it in there and that sort of stuff. I'll actually do that as a separate thing, so we'll just have one. But because I want to show the complete process here, we want to spec out that file, write an example writer and example reader for it, so that we've done all of that on stream, so that anyone who wants to duplicate that stuff can, right? All right, so let's keep going. What we want to do now, and since this stuff, again, we're just kind of porting things out here. So what we ended up doing here was, you know, we had cut and pasted this code a little bit too early. So what I think I might do is just go back, because this was before the simplification that we did in here, where we got rid of sort of the debug information. In fact, I guess inside Handmade Asset, we now have some stuff that isn't necessary, right? Like we don't need bitmap and sound count anymore, do we? Right? They're just totally unnecessary. It's only asset count that matters, I think. Yeah. So what we should be able to do now is we should be able to grab this code here, right? That's now been greatly simplified, so it should be much easier for us too. We should be able to do that and paste that into the asset bundler here and have it all work out. Now, I do need to go re-enable building it, because I think we turned that off yesterday. So let's go ahead. There's that asset builder. Here we go. And so all I'm going to do here is I'm going to go ahead and, I guess, why even fight it? Let's just go ahead and make game assets be a thing. Off we go. Right, there we go. And all of this stuff can just kind of live in there, and it should compile. That way I don't have to even do the replacement. So v2 align percentage, I'm just going to quickly change that to these two, so we don't have to pull in the math stuff unnecessarily, since I don't want to bother doing that. What is the thing? Oh, bitmap ID. And so we can also pull those guys in from Handmade Assets, so sound ID and bitmap ID, like so. Go. And then I think we should be good to go here. So, all right, so we don't need to do push strings anymore, because we're not doing dynamic code reuse or anything here. So that can just be file name directly. And I guess we also have to fix this asset stuff here. We need to go ahead and put in the union like we had before, so we can store the sort of bitmap and sound info as well, like so. So there we go. And yeah, let's go ahead and compile that. Align percentage is now going to be one of these guys, right? So we've got it set this way. And again, we don't care about arenas or anything here because we won't have to deal with any of that. And next ID to play dot value must have a. So isn't next ID to play? Isn't that a sound ID? What? Why did that not work? Next ID to play. What was the problem there? Sound dot next ID to play dot value must have a class union struct. It does though. Oh no, we removed that. It looks like. So all right, sound ID. All right. So asset tag ID. That is probably something that should go in the common area. And remember, we made a place for this. It was type ID here, right? So it can kind of go in there where we're defining those sort of permanent things. And then I think we may be good to go. So what I'm going to do here is leave this code pretty much intact. I'm going to make a little, you can see this is a little pattern I will occasionally use. So if we go ahead and take the game assets structure like so, if I was to do this, right, then all of these guys which are expecting a pointer, I have to go change them, right, to pointers. But since I was keeping the code basically the same, what I can do is just put an underscore under it and take the address like that. And now, right, it all doesn't, none of it needs to do that, right? So that's just a little like sleight of hand that I will occasionally do. So all right, add bitmap assets. These guys need to default to 0, I think, or is it 0.5? I think it's 0.5 is what they do default to, but I'll double check what we were actually defaulting to. Yeah, it's 0.5, 0.5. See it right there. So I think that's really most of what we would need to do. I suppose I could have been clever and done that a slightly different way, but maybe we don't want to be all that clever all the time. So let me go ahead and change hero line here to hero line 0, comma hero align 1. And then we will be done with that. Can't see what happens behind my head. All right, there we go. And what is this saying? Cannot send ID to asset star. That is true. In fact, this code now just needs to. This is just because this code was copied before we sort of finished doing the port yesterday. So if I just go like this, I think we'll be good, right? If I just go ahead and use the new code, we should be good. And then we'll need the isValids, although I don't really know. In fact, I don't really know if we care about that. I could just do this. Last music is a star. Oh, that should be a sound ID as well. All right. I think that's it. Just about. fopen, this function or variable may be unsafe. Consider using fopen_s instead. Yeah. Thank you for that helpful warning. But no, this is not a high security operation here, my friend. This is a offline asset processor. So in test asset builder, I would like to go ahead and disable that warning. I guess they're saying I just pound define this to disable that warning. So there we go. And off we go. Okay, so we're now building our test asset builder, so that's good. But we're not actually writing anything out. And we also need to do one thing, which is, you know what, I might want an H file for this. So I think I'm going to have an H file where I can quickly view these things. So there we go. Now I've got an H file in here. Just make that look like that. All right. Pound include test asset builder.h. Lovely. So really, what we need to do now is just initialize game assets, right? So right in here, we want to initialize anything in here that we want. So bitmap count and sound count and infos, these are all, like, we don't care about any of that stuff anymore. That stuff's gone. And so we really only have to deal with these guys. So we've got tag counts, and we've got these guys. That's it, though. That's all we're going to have to deal with. So we've got assets, and that is good. All right. So the asset count's going to default to 1 because obviously we have a sort of a null asset at the beginning. I guess how did we, and I guess used asset count, how did we actually initialize these in the original one? I wonder. Let's see, debug used asset count. Yeah, so we could even do this a slightly different way as well, but I'm going to set this to this. We're gonna play around with this a little bit in a second here, but let's go ahead and set that up. Okay. So what I would like to do now, right, is I would like to go ahead and start thinking about how we're actually going to write these out, right? And so what we have to think about is we now have like a table, basically. We have this game assets thing, and our goal is we have all of the assets defined in here. What we want to do is process, go through all those assets and write out a giant file which has the directory information we need, which is this metadata stuff here, right? Like all the asset stuff, the info, the part of it that's info related, right? We want to write that out, and then once we have that, we want to write out actually all the actual physical data, right? We want to write out the actual bitmap data and the actual sound data all into one file so that it can be accessed, right? That's what we're trying to do, is just kind of merge all those things together, and with the directory that can be loaded, right? So let's just start. The first thing that I want to do is make a handmade asset file.h, which is going to, I guess, you know what? I'm not going to call it that. I'm going to call it handmade file format.h. I think that, or file formats.h. And this is just going to be a thing that defines the file formats that we actually use, right? And again, I want to go ahead and make a pragma pack like we normally do. I assume we did a pragma pack here somewhere. We had one. Oh, you know where we probably had one? We probably had one in the bitmap code, right? Let's see. Did we? Where is that? Let's take a look. Grep. Oh, you know what? That's because we moved it to the renderer, right? Or the asset file, I should say. There it is. So if you remember, C, when you define a structure, introduces padding to make sure things are aligned. And the padding can be different depending on the circumstances, obviously, and we don't want it to introduce any of that padding, right? So what we want to do is define things exactly how they're going to be in the file. And so we want to enclose our definition of our file format structures. We want to enclose them inside a pragma pack push and pop so that we know that the exact format that we specify in these structs is going to be what's actually written to disk, right? So the first thing that we should probably do is we said that we're going to have a handmade. Remember, we sort of said in here when we did that test asset builder, we said that it was going to be an HHA file. So we probably want to have an HHA header, something that starts the file, so that if you were to open one of these files, you could test to see by looking at the header whether or not it was actually a Handmade Hero file or not. This is a very common thing in file formats, and you've seen it already in the file formats that we've talked about so far, right? If you look back at the stuff that we've loaded in Handmade Hero already, right? You can see that we've always done these sort of things like, oh, when we load the header in of this wave file, you should always see this like riff chunk header and this wave ID, these sort of values we predefined, right? They're just nothing more than just specific values that are stuck in the file to let you know that it is what it says it is, that it is in fact a wave file, right? And so we know that like for the wave files, it always starts off with the letters RIFF and then a size and then the letters WAVE for if it's a wave file, right? So we know that we're expecting to see that. And, you know, do you absolutely need that? No. But it's just this nice kind of thing for error checking where your code can always look to see when it opens up a file, does it see these things that it's expecting to see? If not, you can raise an error. And it just helps in debugging, you know, to sort of say, oh, you know, I think there's a problem here because we're opening this file and it's garbage or whatever. You know, at least you can tell whether it was actually the right kind of file or whatever. And so these are typically called magic values, is what they're called. They're called magic values because they have no actual reason for being there. It's not like the value was picked to mean something. Instead, it's just a purely magic random value that you pick that lets you know that it is you know, such and such a file. So what we might want to do is put in a magic value there, right? And the magic value we could just pound define to be like some, you know, we're going to have a specific pattern that we always expect to see at the beginning of a Handmade hero file. Now, unfortunately, H is not something that we can really represent because, you know, as you know, hexadecimal stops at F, right? So Handmade hero is not really possible. You know, I'd love to make the thing be like, you know, something something like that, you know, but there's really no way that we can do that. So I don't know what the magic number really should be. It's a good question. I guess what we could do is take up a letter from the riff code playbook, or sorry, take a play from the riff code playbook here, and just use ASCII characters to say something. That seems like a totally reasonable thing to say, and we could just say that we wanted to make a similar thing to this here, where we were going to do like, okay, let's do an HHA code, and since we are, I guess since we are little endian, the way that they do it in Riff is good. It's going to be like the first thing first, and that's all fine. So we will make an HHA code, and the HHA code could just be HHA and Handmade hero asset file. So there we go. HHAF. That can be our magic value. So we'll just stick that at the beginning of the file, and that just lets everyone know that this is a Handmade hero file, lest they be confused about that, right? So I think that's all we really want to do. Some people like to put a version number in here, right? I don't know how much we care about that because I don't know that we're going to rev versions of these things in that way. But we could, since it's free to stick it in there, we could stick it in there. And we could do version, say this is version 0. Right? And so those would just be prescribed values that are set to HHAF and 0 on disk when we write it out. And so then after that, really all we're looking for now is we need some way of starting to define where our data is. And so if you take a look, you know, I realize maybe some people haven't done this before, so I want to kind of take it a little slow. This is really very basic stuff we're doing here. But if it's your first experience with defining your own file, it may be kind of confusing, right? So I just want to kind of underscore what's going to happen here so that you can kind of, you know, attach it to something mentally. So what's going to happen, right? When we load in one of these files, we're going to load in a chunk at the beginning of the file, let's say, right? That is that header. And based on what's in that chunk, we need to be able to know how to get at more data. So we have that magic value and we have that version, right? And those are just there to sort of verify that the thing that we're about to load, we have the capability to load. Like that it is a Handmade hero file in the first place, and that it is the version that we expect it to be, because, you know, if this is a thing that supports version 0 and is trying to load some Handmade hero file from the future that's like Handmade hero version 7, well, that's not going to work, right? So those are there for our verification purposes. So then the rest of the header, what we want to do is when we load this, we're then going to be stuck, basically. We've just got a header. We don't know what else is in the file or where it is or any of that stuff. So the next thing that we need in that header is some information about where in the file we would look for other things, And also some information about how many other things there are or things like that, so that we can prepare our memory in the game to load it in, right? Because we don't want to have to do like parsing of it, or we don't want to waste a lot of time because we're controlling the format of this file. We are pre-processing it to make sure that it's efficient for us to use. And so what we want to do is we want to just like give the game the maximum amount of information it can get so that it can be very efficient when it loads these things in, right? And so that's the next part that we want to do here. And we already sort of know what we need to put, right? Because we know we have assets and we know we have tags, right? And so what we want to do is we want to put information in here that will sort of tell us, where are the assets? Where are the tags? How many of them are there, right? And so I, was aware of this sort of stuff when we were kind of working on the asset file system. I've done these sorts of things a lot of times before. It's stuff I just kind of know how it goes, right? And what sorts of things I like. So if you look at the way that I've set this up, it's already set up kind of like it would be in a file. There's like a block of tags and a block of assets, right? And a block of asset types. And you can just imagine how we're going to do this. We can pretty much just do a fairly direct sort of way of writing these out, right? So let's go back to the test builder here, right? And take a look at what we actually have to work with. So we've got some number of tags, and we know that we're probably not going to have more than 4 billion tags, right? So having a tag count that's 32-bit is probably going to be more than enough. Same with assets. We know that there's probably going to be less than 4 billion assets. How do we know this? Because even if each asset was only 1K in size, that would be 4 terabytes, right, of gameplay footprint. And well, maybe sometime 10 years in the future, everyone will snicker at the fact that we thought 4 terabytes was a lot, but as far as Handmade Hero is concerned, 4 terabytes is never going to happen. So we pretty much know that 4 billion, which is the maximum number we could set in a 32-bit unsigned integer, we pretty much know that 4 billion is going to be fine for the number of things that we have. Now, it wouldn't necessarily be fine for the total size. We may want a total asset footprint size of greater than 4 gigabytes, right? That's not out of the question. So in terms of talking about places in the file may need a 64-bit offset to say where in it you are. But in terms of how many of something, of actual individual assets there are, a 32-bit value should suffice. Okay. And then we've got asset types, right? And sort of what I said about the asset types is those are going to be done a little bit differently. So when we say here, we kind of have asset type entry count. And the reason that I said that is if you remember from the previous day, what I said is that we have this asset type table, and I want to actually allow it to say what the asset types are that are represented in that table, rather than just assuming that they are 0, 1, 2, 3, 4, or whatever, because we may have only certain asset types represented, and we may add new asset types, or who knows what goes on there. And so what I want to do is just allow that to be a little bit different, right? So we have a tag count, an asset type entry count, and that's really all that there is that's going to have to be in this file. And everything else will presumably be offsets off of that, right? And so what we need then, again, in addition, is once we have that information, we need to know where we would find those things. And so what I want to do is say that there's like, a tag array offset, an asset array offset, right? And a an asset type entry array offset, right? And I guess I don't have to say array. You could just say that, right? And so the idea here is you read the header, you know how many of each of the things you're going to have, and then these offsets will tell you where in the file you actually need to go to get those arrays, right? Hopefully that makes reasonable good sense, right? So then what we need to do is we need to actually define some of these. So stored on disk, what does a tag look like? And for now, these are mostly just going to be, you know, cut and paste, right? Because we're not really storing much in the game about these things, so they're going to look very similar, right? So we have a tag offset, right? And this is basically going to be, you know, this offset in the file is going to store something like this, right? It's going to store an array of these guys. The asset offset here is going to store an HHA asset and an asset count of those. And same thing here, HHA asset type entry. And I guess I don't really need to say entry. So no sense being overly verbose. Like so, right? And we could even pluralize these. There we go. And so, yeah, do I like it? Yeah, maybe at. Kind of like that as well. Or I could even just do it this way. Who knows? We'll see how it goes. Anyway, so if you take a look at basically what we're doing here, we're just sort of defining on disk the sorts of stuff that we want to store and how it's going to be stored. So that's all easy enough. And so now we just need what each of these things actually would be storing in it, right? And so here we go. The asset type, like I kind of said already, is just going to be the type ID for that asset type. And then it's going to be like the first asset index and then the asset count, right? So it's going to be basically the same, right? Oh, I guess we did one pass last, so that's how we did it. So it's going to be basically the same, right? Except we're also going to store the type ID. So it's not just going to be implicit in the load there, right? And then for our HHA asset, our HHA asset is going to store basically what we've written here in the builder, because I guess I already kind of did it a little bit here, right? So it has what its first tag is, it has what the one past the last tag is, it's got where its actual data is stored, right? Whatever that happens to be. And then it needs to store whatever the info is that we're going to store about these things. And this is going to be a little bit different, right? So these, we're going to have HHA like bitmap and an HHA sound, right? Like so. And what we can do here is just, these are probably fine as they are, right? We kind of know the next ID to play. We know the sample count. These are all the same. The difference here is we're not going to have a file name in either of these cases, right? So for right now, we don't have much else that maybe we would need to know. Although actually, you know what we do? We actually do. Because the other thing that we have here is we have the width and height. So we have the dimensions, right, of the bitmap. Because remember, once we include the bitmap data directly in the file, we will no longer actually know what those dimensions are if we don't store them. Because the reason that we have them now is because when we load the bitmap file, we look at the header, right? But we won't be loading bitmap files anymore. We'll be loading data directly out of our file, right? So yeah. So I think that's pretty much it, right? And you can sort of see what we've got here. It's not particularly complicated, but there it is, right? Okay. So yeah, not a whole lot to it. I'm going to go ahead and say let's organize it this way for now. I think that's everything that we would really need. And you know, we could store what type of asset it was here, but it's kind of just implicit in how the game references it. So we don't really even need to do that. We may need to do that over here, but we wouldn't necessarily need to do that over here. So we'll see if we want to include those or if we don't want to include those, right? But the way that would look is in here, we would include a type field that says, is this a bitmap or is this a sound in the asset field, right? So there we go. So that's that, really. Yeah, I can't think of anything else. So let's just start. Let's start writing it out. So if we come down here, let's go ahead and compile. If we come down here, we need to include this handmade file formats.h, right? Handmade file formats.h. There we go. And I will just go ahead and start writing this out. So the first thing that we need to write out is the header, right? And so we need one of these guys. But there's a little bit of a caveat here, right? Here's the header. And so if I want to actually set this, I can set it all up. I can say the magic value is, you know, the HHA magic value. I can say that the version is the HHA version. But then I got a problem, which is that I don't really necessarily know some of this information. I do know the tag count, right? So I can say that the tag count is the assets tag count, right? I do know the asset count, right? Oops, count, assets, asset count. And I do know the asset type count as well. Well, I don't even really know if I do, because we don't know which of those might be filled. So we don't necessarily know that, right? We don't necessarily know that. But what I definitely don't know at this point is I don't know necessarily where these things are, right? So I don't know what the offsets in the file are, right? You know, where are the tags going to be? Where are the asset types going to be, right? Where are the assets going to be? I don't actually know, right? I have no idea where those are going to be. So, you know, I could start writing in code to compute the layout here. I could be like, oh, you know what, these are going to go at a particular location. And maybe I should do that just to show you what that looks like. And then I'll show you some ways to avoid having to do that. So maybe today we'll do that, and then maybe this will be a good way to break it down. Today I'll do it that way, and then tomorrow I'll kind of show you, okay, we can save some work there, right? And maybe that'll be a good thing to show. That's now I think about it, that's probably a good idea. So yeah. So asset type count, we're not really sure how many of them actually got used. For now, I guess what I could do is just say that we're going to have have an entry for all of them. But I'm going to put a to-do there, which is like to do, you know, do we really want to do this? Sparseness or something. So then, yeah, if I was going to compute these, right, where do the tags go? Well, we can just put the tags, we're going to write the header in. Right? So the header is however big it is, right? The header is this big. So we know that the first place in the file we could start to write an array would be after the header. So that's where that would be, right? And then the asset types would go wherever the tag array started, it's going to go tag count number of tags past it, right? So, you know, something like this, where I'm going to say, all right, you know, I've got this many tags that come after it, so that's there. And then the assets, right, are going to come after that. So it's going to be wherever that was, plus however many asset types there were, right? So however many we said there were going to be of that, times the asset entry there, asset type. So that is where the things are going to be in the file. And you can see that basically I have to kind of do a bunch of math kind of in my head there, which might be a little error prone. But for a file, so far our file is very simple. You know, we could, you know, we don't even really need, maybe we don't need to actually address that. But there's ways we can certainly make that better if we do decide to, right? So that's the header. And, you know, now I can write the header, right? I can go ahead and say, all right, let's write the header out. Fwrite is the equivalent to write file, like we were using in the platform layer. And it allows you to say, I want to write something of a specific size, and here it is, right? So you give it the information, and it goes ahead and writes it, right? Now there's a weirdness to it. It's kind of annoying. In fact, sometimes I don't like using write. I like using the slightly lower level ones, and I'll show you what is weird about it. But just so you kind of, if you ever choose to use it yourself, what you can see is instead of, you know, you pass it the pointer, which is like what I'm going to write, and you pass it the file handle that you want it to write it to, which all makes good sense, right? It's almost exactly like we did in the Win32 layer. But then you've got two different sizes. You have a count and a size. And the way that fwrite is defined is that it will try to write, you know, this many things of this size from that pointer. And it will return to you, right, a value that's representative of that. So if you look, it's the return value isn't how many bytes that were written, it's the number of elements that were written. So if you set the size to 1, then you will actually get back the number of bytes written. But if you set the size to something else, you'll get it divided by that, right? It's just, I don't know why, they probably had a good reason, I don't really know. So yeah, so what we probably want to do is say, oh, the size is, we just want to write out one whole big block. So we probably want to say, write out a single unit of this size, right? That's just blam, just write it out, and you're done. Okay, so we're going to do that, right? What we should also do is just verify that we can open the file, right? So I'm going to go ahead and do a printf here and say, error, couldn't open file, right? Whatever. So yeah, so that's going to write out the header. And of course, the way that the C runtime works is it keeps sort of an idea of where in the file you are. So you start out writing at the 0th byte, and after you write the header, you're then pointing to the thing immediately after it, right, in the file. So it's kind of a streaming write paradigm, which, by the way, I absolutely loathe. The concept of streaming, just the concept that file handles have a position was just the worst thing. So bad. It's so bad. But yeah, what are you gonna do? Anyway, so that's how that works. So you'll notice that when we said, you'll notice that even though we're specifying 2 numbers, they're both just size. Nothing here said where in the file to write. And that's because it's just implicit that it starts out wherever the file handle was, and when you write it, it moves that far forward, and then you write at the next position. And you can seek in the file, but if you want to do a seek and a write together, it's 2 separate commands instead of it being 1 command. In my opinion, that should never, ever, ever happen ever under any circumstances. It was a very bad idea. It's the worst possible way for a file system to work. What you want is you always specify the location and the size. And the reason for that is because you don't want the hidden state of this file position. You want to introduce that at a later level, because otherwise it causes all sorts of problems with like threading, where 2 people use the same file handle and they got the pointers are now, one guy uses it and it's in the wrong place, and you can't queue up the writes because you'd have to save where the file handle was in order to figure out where the person thought they were writing at the time they wrote. It's awful. So yeah, really don't like it. Just using it because I wanted to write this simple app here, and I said I would show to use the C runtime library, and it's totally fine to use, but just be aware that it's just a bad, bad, bad API. The worst idea for a file API that we've ever had, and unfortunately it's the default. What are you going to do? All right. So what we want to do now is write out these actual arrays. We've got 3 arrays to write out. We've got to write the tags array, right? So we want to write out the tags array here, right? And like so. And then we want to write the asset types array. And then we want to write the assets array. Now what you can see here, these question marks here, which are the sizes that we're going to write, we actually already know what those are because we use them up here, right? So what we want to do is we probably want to reuse that work and just say, okay, we've got some sizes here, and I guess these sizes have to be restricted to U32s at the moment because we're using a 32-bit write, but that's fine. They all will be. So right here we have the tag array size, right? Tag array size, like so. And then here we have the asset type array size, right? Asset type array size. And then finally, we didn't do the assets one because we didn't actually need to put anything after it, but we will eventually. So we have the asset array size, and that's just going to be the header asset count times size of HHA asset, right? And I guess, let me see file formats here. It's tags, tag, asset, type count. So that should be, I want that to be lined up. There we go. Okay, so now we actually know what those sizes are, right? This is the tag array size. This is the asset array size. And this is the This is the asset type array size, and these are the assets, right? And so now what we really need to do is we just need to actually build these guys, right? We need to actually build the actual arrays here that we're going to write out. So we can compile, and everything should be fine, but we haven't actually, we haven't actually constructed these. Asset array, asset type array, tag array. So yeah, so that's it really, and that would give us a file who's had its headers structured properly, right? But we need to actually produce those. So let's take a look at what we've got here. Now, if we actually just made these be exactly, if we actually just produced these by using the HHA and the tag and stuff, so we could do that for some of our stuff. For tags, for example, we could totally do that, right? So if we make this be an HHA tag instead, right, and got rid of asset tag, nothing would change, right? I think everything would just be fine, right? And so then assets tags is just the thing we constructed in memory is actually exactly the thing that we actually wanted, right? It's just totally the right thing, right? So that's totally easy, totally fine. So then the question is, well, what else can we do that with, right? Asset type, that thing here, we could totally do it with that as well, right? Because what we could do is just, well, that array we're kind of going to have to compress. So, well, no, you know what? We totally could. No, we could totally do it with that as well. We could totally do it with that as well. So let's go ahead and do that as well. I'll just get rid of asset type here and change this to HHA. What did I call that in here? It's just asset type. Yeah, it is. HHA asset type, right? And we do know that we can never have more than asset count of these. So what I'll do here is just call this, in fact, I'll start to break these out a little bit more, right? So we have the tags, we have the assets, we have the asset type count as well. What I can do here, and these ones also, can sort of start to go away, and we can clean that up a little bit. But if I go ahead and do that, then I can also do this asset type array, like so. So I'm going to go ahead and just do that, asset types. All right. So yeah, if I do it that way, then what I'd have to do, though, is when we are actually doing the entries here, what are we talking about? Right, HHA asset type. Yeah, so if I actually do it that way, the only thing that we would have to change is when we do begin asset type, right? When we do this type ID here, when we set what these are, the only thing I would have to do is just store it, right? Store the type, because that's the only thing that we actually changed in the entire thing, right? So now our asset type array also conforms to the file format because it's actually storing the type ID, because the rest of the stuff was the same, right? So the only thing that we had to do is stick what type of asset we were talking about into that array. And so now we've done that. So the only thing that's a little bit squirrely is that assets, because those are the ones that actually store to different things, right, depending on what we're doing. And so let's just go ahead and comment that out for a second, since we're out of time. So this code, let's actually just step through it quickly, because I want to sort of show you what we're doing here. If I go ahead and do msdev wbuild test asset builder exe. Oops, I think I maybe did a not so good batch file. Ah, yes. You'll notice we made a little batch file so I could type msdev instead of devenv because I'm so used to typing it, but we didn't pass any arguments to it. I think that's the way you do that, right? There we go. So when I actually called that, it didn't actually pass the fact that I wanted to open that file. All right. So what I want to do here, I've created sort of a new debug environment by launching with the test asset builder instead of our normal exe. Because I just want to kind of step through this. So if I go ahead and set this this guy's directory to be looking at our standard handmade directory the way that we do, right? Handmade data, like so. Then if I start step through here, oh, no debug for the file? Do you want to continue debugging? No. Did I not specify debug info? What happened? What happened? Minus Z. It's got Z7. So why does it not have debug info? Dare I ask? Where's the compilation line? So builder, link, common, linker flags, incremental no, opt ref. Seems a little odd, doesn't it? Like, why is there no debug info? Oh, do we like delete? Ah, because we delete the PDBs here. So we really probably want to push this up like so. There we go. We were deleting the PDBs because that's part of our little build process that we were doing. All right. So here we go. We come through here and we're going to generate all our assets, right? Just the same way that we were doing them before. Oh, or not. What is the problem? Assert debug asset type is less than asset. I guess I should mention and fix. So in the way we were doing it before, our asset count in the game was actually doing the total number of these things that you could have at all. So these asserts are no longer actually meaningful, right? Because asset count actually tracks the actual number. So really what I think we should do here, sorry for going over time. Sometimes you know how it is. I'm in the middle of something and you got to do it. I think what we really want to do here is just get rid of those, if that makes sense, and go ahead and clean those out. Because what we really want to do is just have it be, always using actually the asset count itself instead of having that debug value, right? It's just whatever the actual asset things are. So there we go, because we need that count for our other stuff as well. So let's see, tag count. What is this? This is just asset count. And then these guys go away. All right. So now we can get rid of those assertions because I believe this will always be, that's never going to actually be possible. Oh, you know what I could do? I could do array count assets, right? Since those are static arrays now. Do we have any more of those assertions anywhere? Yes, we've got one right above it. So that is this one, right? Array count assets. Because those, remember, we were dynamically allocating those in the actual game, whereas now they're just static arrays. So, okay, we've defined everything here, and we can take a look, right? This is the assets sort of meta structure that we've created here. So, like, you can look, here's all the tags, right, that we've made for whatever. Looks like we don't have a whole lot of different tag types being used. That's because we didn't really play with the tags much. And we've got the asset types defined here in this array, right? And then we've got the assets themselves. And it looks like those are valid and all that stuff, right? So now we're going to come through here and actually write out the file. So the first thing we do is we prep that header, right? And you can see it. Here's that magic value, right? And we can even see if we tell the debugger I'd like to look at that as an actual char star. You can see the HHAF that we wanted there. And so here we're just prepping the header saying there's 13 tags, 17 asset types, 51 assets, and then the offsets we haven't specified yet, right? So there, the header itself is 44 bytes long. So you can see that the asset tag array is going to start on the 44th byte, and then the type array is going to start after that. The assets are going to start after that, and then we're just going to write them out. So that writes out the header, that writes out the tag array, that writes out the asset type array, and we haven't finished the assets yet. We fclose the file and exit, and that is our asset file, right? not done yet, but that is the entire process, and you can pretty much see it's really not very complicated. We're really just going to basically do that again tomorrow. And there you can see the test.out file that we have produced. Now, I don't actually know if I have anything on here that can view. I don't know if I have a hex editor on this. We may have to download a hex editor. I could use Emacs's hex editor is like the worst. The worst. It's just awful. So, you know, this is not a long-term solution, but whoa. What just happened there? Am I missing something? Is that actually, how did we manage that? Is that actually what, oh, that's test.out. I want test.hha. I was going to say, I almost freaked out there. I was like, how did that happen? So I'm going to try Hexel mode. I don't recommend doing this at home. It's awful. But, you know, just to give you some perspective on what happened. So this is looking at the actual file that we wrote out in Hex, in a hex editor, so we can just see what the actual data is. And you can kind of see that we got exactly what we expect, right? Remember, a U32 is 4 bytes long, so here are those 4 bytes, 1, 2, 3, 4, and they are HHAF, right? Then we had the version number, which was also 4 bytes, and it's just set to 0, so there are the 4 0 bytes. And you can just go ahead and read these directly out, right? Then we have the tag count, right, that was in there as well. And you can see, now remember, it's little endian, right? So the lowest order thing comes first. So that 0D that's the tag count, right? If it was more, if we had a lot more tags, you would see numbers up in here as well, right? But we only have a very small number of tags so far, right? So there's a tag count, and you can just see that it getting written out here. And then we wrote out, the various, this is like the tag array out here, and the asset type array, right? And so that's all we're doing, really, really straightforward. It's really just a question of taking the stuff in memory and writing it out. We're doing the simplest possible file format stuff. And so that's like, that's all we're trying to accomplish right now. Now, I don't actually even remember how to get out of Hexel mode. I remember it's you can't Alt-K. Kill buffer. Yes, thank you. All right, so I guess we'll go ahead and go to questions. So let me go ahead and start the Q&A. And tomorrow we can go ahead and finish up writing those things, right? So if you have questions, please prefix them with Q:, and so that I can see them. And yeah, if you have a question about what we're doing, if you have an off-topic question, please save it for tomorrow's pre-stream. Gasto5, why is a position for a stream a bad idea? So essentially, it's because it's hidden state that is easy to get wrong, and you always should know where you actually are going to be. So I'll give you a couple examples, right? So let's suppose I say write, chunk A, right? I'm just going to say write A, and we know that means chunk. And then I'm going to say write B, okay? This is the stream position way of doing things. I say write A, I say write B, right? This is the bad way. Here is the good way. If I instead say write, location A, write location B, B. Okay. So I'm saying this is good and this is bad, right? And so the question is why? Well, the answer is this always works in all circumstances, no matter what you want to do. So if your API looks like this, where you say write the location and the size, right? This will always work. This only works for single-threaded, very simplistic use cases. And I'll give you some examples. So let's say I want to have this be, if I'm just executing this simple, basic single-threaded, right? So I come through, and here is my file, right? And I say, I want to write A, and here's location A, and I happen to know the file pointer is pointing there, so it writes in A, and we're happy, right? I then come and I see B, and I'm like, okay, B goes here, and that happens to be where I wanted B, and so it's all good, right? That's the stream version. That's what you wanted to have happen. Now, suppose I now do something where I say, oh, you know what? I want to queue up my writes, right? I want to queue up where the writes are going to be, right? And so these are going to get added to a queue. So I go ahead and I add write A and I add write B. I say, you know, I do add and add. Well, the problem now is, let's suppose that queue, maybe that queue is an out of order queue, right? Maybe this gets added such that it's going to pop off first. So now what happens is when they pop these things off, it pops off B first, right? It's like a stack, let's say. So it pushes A, it pushes B. It pops off B. That means B gets written first at location A, and it's longer, so who even knows where A ends up? A ends up somewhere out here. And now you've got things in the wrong order and in the wrong place, right? So not good. So already, even in a single threaded case, if you queued, you'd already have to start storing this information. So behind the scenes, if you did have a streaming concept, it's going to have to record where in the stream it thought you were writing anyway, right? So that's just going to happen. So that's going to happen. So that's that, right? Now let's suppose it's multi-threaded, because now things get even worse, right? If it's multi-threaded, I don't even know what's going to happen here, right? So let's suppose that my entire interface to the operating system, I guess the other way to say it is, in this case, I could fix this by saying, okay, all queues have to be first in, first out, right? And then this case would work, right? I just guarantee that if I pushed A first, then A comes first and then B. And then I don't need to store this, right? But let's suppose that I then say, okay, we're going to have things be multi-threaded, right? Yeah, because that would still allow me to do this, right? So let's say I want to fix that, right? And I want to do something where it's multi-threaded, so I don't know what the file handle is actually, where the stream's actually going to point, right? I don't know, so I want to be able to say, well, let's always make sure the file handle points to where A is, and always make sure the file handle points to where B is, right? So I write a thing that's like seek to location A, write A, seek to location B, write B, right? So I'm saying, well, all right, you know, it's multi-threaded, so I don't know, or you know, I want to do these out of order, right? Or I don't know what order they're being done in. So we're basically saying, oh, okay, I can emulate the good API by just doing, you know, the C-run has seek and it has write. So I'll seek to where I want to write, and then I'll write. I'll seek to where I want to write, and then I'll write, right? Surely that will fix the problems that we were going to, you know, any problems that we were going to see, because it makes sure that I'm always at the location that I think I'm going to be at, right? Well, the problem is multi-threading totally breaks this. Because if you seek to here, right, and then you expect to write at that location, at any time, if this was thread B, right, here's another thread. I guess I'll do, well, I could do thread, just to avoid confusion. Here's thread 2, and here's thread 1. If thread 1 executes its seek, but then gets preempted, and thread 2 starts executes its seek, then does the write, and then we pop back to this guy at some point, and he tries to do his write this seek doesn't matter anymore, because it got overwritten by this one, right? And so it's absolutely critical that the seeks always be bundled directly with the write in the actual part of the API that actually does the operation, right? Because otherwise, no matter what you do, if you have to do this at some point, you will break in a multi-threaded scenario, right? So that's awful. It's just really, really bad. Never, 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 ever have your API do that. It's awful. Now, if you want streaming behavior higher up in the API, you can always make a little thing that's like, you know, struct my stream, right? That's like U64 position, you know, file handle or whatever, right? I mean, you know, file or whatever, right? And you just issue your writes through this thing. It looks at what the position was, issues the proper write in this format, right, to the you know, that needs to happen, and then increments position by the amount. And now you know that because this is unique to your thread, you will never have to deal with the other problem, right? So that's the right way to do it, in my opinion, because then another way to say this would be, if you do it this way, it means only people who actually care about the streaming part ever deal with it. Whereas if you do it this way at your lowest level, what that means is that most people who don't really care about streaming, because most of the time you're loading chunks out of a file in a multi-threaded way, and I'm getting this batch, whatever, right? If you do it this way, what you then will have to do is you'll have to proliferate the number of operating system handles you actually have if your operating system works this way, right? Because if your operating system only allows you to do seek write, that means that every thread has to have a separate actual operating system handle to the file, because there's no other way to make it thread safe if you don't do that, right? Whereas if your operating system API is just always location plus contents, right? Then all you have to do is the few places that you actually want streaming, you just implement it, right? And then everything's nice and clean. And you only need one handle to the file no matter how many people are accessing it, right? You never need multiple OS handles. So yeah. So I really hate this. I never ever like this. And I almost always never, I almost never actually use much of this sort of thing in exactly this way. I find that when I actually do want to do something like this, it usually wants to be more complicated anyway. So the crappy one that's built into the OS for me, I never want. I don't want that one. It's not good, right? So I find that typically, even if the OS has the streaming, I have to duplicate that streaming myself because I want more abilities than it gave me or whatever, and I want it to be more convenient, right? If I'm going through the trouble of making this API where I'm saying that having the ability to talk about things lining up in certain ways is beneficial, I typically want more than what the OS gives me. So hopefully that gives you some sort of, what's what I'm looking for, perspective on just why I have an aversion to it. Are you concerned that trusting the file format could have security concerns, e.g. someone could say they've made some modded assets and give out a specially crafted HHH file that runs arbitrary code? No, I am not really concerned about that pretty much at all. And the reason for that is this is not like, this code is not going to be designed for security, right? Like, we are not going to try to make this a mission critical kind of app. So it's just assumed that, you know, if you are for some reason running Handmade Hero with elevated privileges on your machine or whatever, you know, all bets are off. I have no idea what it's going to do. It's not my responsibility. It's a game. It's not, you know, it's not going to be put through the kind of security analysis that you would need to do in order to have that be true, right? So yeah, so I'm not concerned about that, about the fuzz testing aspects of it, if that makes sense. What we and what I would suspect would be the case in general is that, I guess what I would say about that is, it should be the case, like let's say Microsoft was competent, right? It should be the case that you would never even remotely have to think about what you just said, right? Because it's a game. It doesn't need to send email. It doesn't even need to connect to the internet, but you know, whatever. It doesn't need to write to anything on the hard drive other than a small area to do save files, right? It needs to do essentially nothing. And it would have been trivial for Microsoft for many years to make Windows such that it could run a game with no risk to the user. It would have actually been very, very easy for them to do that. Pretty much the only thing that isn't easy about that is the GPU security part of it, right? But they have chosen to make it almost the opposite of that. They've basically chosen to make it so that you can't really even install a game most of the time without having administrator privileges, and you oftentimes have to run it with elevated privileges anyway. And so it's kind of sad that this is even something you have to think about, because what you're talking about could easily happen. Like, most games can be given data files that would allow them to execute arbitrary code, like pretty much all of them, right? But I really just don't think that is the game developer's responsibility. That is what an operating system is supposed to do. And I am not really willing to spend a ton of time cleaning up after Microsoft's fault, because they're the ones who charged you $199 for software whose job it was to make sure you did not have to trust random game developers to be security experts. And they are the ones who should be fixing this, right? And I think it's unrealistic to expect game developers in general to even have the security expertise necessary to know whether they've covered all the angles. Could we do some work, some reasonable work to try and bulletproof the Handmade Hero asset file against that kind of thing? Yes. Should we consider ourselves qualified to actually say that it is, bulletproof? Absolutely not. I'm not a security researcher. I have no idea all the things that could be happening there. And so, to really do a thorough security audit on our code, I think is way out of the question, and definitely not something that I would ever want to undertake. Certainly, it's way beyond my sort of area of expertise, if that makes sense. What is the main difference between using asserts in your code and writing separate test functions, programs that check your results? And when do you choose one over the other? So asserts are the preferred method typically in game development, because most of the time in game development, it is difficult or impossible to write actual inclusive tests, like tests that actually cover all of the things you might want to do. So most of the time in game development, you'll be dealing with asserts because writing separate test code is infeasible. It's not to say that you couldn't write separate test code that tests some things, but those things are usually the least interesting things. They're going to be the things that are least likely to be the bugs that you will actually have trouble finding. And so asserts are a lot more valuable because you can put them everywhere and they catch bugs at runtime when things are actually happening in real scenarios, not fake scenarios that you've created in your test programs to try to see if you can find bugs. Now, when you would actually use a test function, it's when you would like to bulletproof something in anticipation that the bugs in it will be subtle or hard to find. So for example, let's suppose that what we wanted to do was really make sure our mixer didn't have any bugs in it. Well, we could easily write some test code that would pass a bunch of different kinds of buffers to the mixing code to see if we can get it to fail. And what I would point out there is we probably would still use the assertions in a lot of cases to find where the bugs are. And so the test code, in some sense, is almost there to try to make the asserts happen, right? We're trying to force the code into a situation where it's going to hit uncomfortable places for it that are not exercised that frequently that will cause that assertion, right? Examples of places where I have written test code in the past: memory allocators, database queries, to use the term loosely, like the actual code that implements handling a data, like the database code, basically, is one way to put it. Math functions, like when we implement a math function, let's say we were to implement, our own cosine, verifying that it actually lines up with the cosine that we think. That's a very common place to write test code. So there are places, and we might do that on Handmade Hero a couple times as well. Will multiple threads pose any problems to reading the assets file? No, and that's one of the reasons why I was saying, I like to make things be always talking about reading from a particular location. So when we have threads that will read from the asset file, they will always issue queues to the operating system that are like, I need to read this location for this much memory, right? For this much size. If C++ had introspection, would this be a place where you would use it to introspect the types you want to include in the asset pack? Probably not. Like, you're right in that this is the type of code that maybe you might use introspection for, in the sense that, like, writing things to disk, right, is a typical place where you want introspection code. For our purposes, I I've kind of architected it so that we get a ton of leverage from a very small number of things. So we really just have tags, assets, and asset types. And they're so simple that any code that you might use introspection for is probably just going to be dead weight. So the time that what you're talking about would come into fruition a little bit more would be like, let's say that this was not going to be a game that was procedurally generated, and instead it was going to be a game where it was very heavily authored. So we were thinking there were going to be a lot of level designers doing a lot of level design. So we've got all of these things of like, oh, there are traps, and traps point to script code that runs on the trap, which acts as things, right? You might start to have a proliferation of structured, stored types. And at that point, you can leverage introspection to take some of the heat off you for writing that file IO code. In our case, the file IO code is going to be so simple that while you could have used some introspection for it, it's probably just not going to save you that much time in practice, right? And so, yeah, just to answer your question there, it's like, what you're saying is totally right. It's just in our game, we've kind of just don't, part of it, it's the procedural generation aspect of it, and because we're smart about it, we were smart about how we organize things, we just don't have that much work to do here. But it is the kind of a place where in a game that needed more from its backing store, where yes, you absolutely could benefit from C++ having introspection if it did. Are there any specific times your streams start and end? Yeah, actually there are. If you go to handmadehero.org, the tweet bot that's there, you can click on tweets. You can either subscribe to this or just check it, and you can see when the way that it works. At the beginning of the week, it will show you the schedule, and that will tell you when it will be live. And usually what we do is we're on stream anywhere from 5 to 30 minutes beforehand, just kind of hanging out and chatting. But then at the scheduled start time here, we usually try to start programming sometime around there. And you can also see that during each day, it will send out a reminder. So if you're just wondering what the stream is for that day, typically there's a tweet that will tell you that. And so that's usually the easiest way to know if you're just on the web or whatever. Why not just read the entire file in as a string and parse it as you please, then do the same for writing? So for writing, anything goes. And like I said, we're not really concerned with writing the asset file. We're just going to assume that we've spec'd an asset file and there's something that will produce an asset file in that format, right? And like I said, I'll take care of bundling all the assets that we actually have up and writing them out into the file, and that's how we'll distribute the art assets for Handmade here anyway. So writing doesn't matter. Do whatever you want. It can be super inefficient. It can run overnight. Who cares, right? If you're doing a game that's developed in a sort of different way than we're doing it here, like where you have you want to do rapid art turnaround, which we don't, Yangshin and I don't even work in the same office, right? So there's no such thing as fast asset turnaround there. And she, kind of does it as a contracting job. She doesn't run the game or anything because we don't have a game to run yet because we're doing it in this sort of weird hour a night thing. So there's all these reasons why we're a little bit different. It's the nature of the project. But you might care about how assets got into the game a little bit differently if you're trying to do fast asset turnaround. But what I would point out there is usually the way you handle that is you have a special mechanism for handling the fast asset turnaround because you want it to be as fast as possible. So typically, when you're talking about optimizing the writing part of things, you end up having a separate thing where you'll write out of band data. Like, it'll just grab Yangshin's PSD file directly and update the assets in place in memory or something. You wouldn't repack it into the asset file to do fast turnaround for her. So that's a whole separate wing of discussion that's not relevant. So I'm just going to tackle the part of your question that's about reading. And you said, why not just read in the entire file as a string and parse it as you please? The answer is because the file is going to be many gigabytes long. Right? It may be bigger than the memory of the machine. It could be, who knows? We want to support a 32 gigabyte asset file. We want to support a Grand Theft Auto sized asset footprint, right? Will we ever have that? I don't know. But we want to support it. And so there's no such thing as reading it in as a string. Like, that's totally off the table. There's no question that's not going to happen, right? And so what we want to do is have an asset file that just has some binary data up front that we can just flat load. And that binary data that we flat load will be, 2-3 megabytes tops. That just is a giant thing that tells us everything about all the assets without actually including the data for the assets, which is the big part, right? The actual bitmaps, the actual sounds are not there. So it's just that. That's that header and the arrays. We grab that in, and then that tells us where we find anything that we need. And so then what we do is, remember, we wrote an asset streaming system. Our game already streams assets. So all we then need to do is have the asset streaming system. We'll just now use that little directory. Whenever it says, oh, I need this asset, it will just go jump into that part of the file, grab just the piece it needs, and continue running. And so that way we can have arbitrarily large files. They will always be instantaneous. No loading times, no nothing. It will just be totally perfect streaming all the time. And that's what we want. Another option is to memory map the file and then do as you will, although they may not work on older consoles, I guess. Okay, so the reason you don't want to memory map a file is you can no longer run in 32-bit. So memory mapping a file requires that you're able to actually map the whole file into memory. And on a 32-bit processor, so on people who are running, say, Windows XP or running Windows 7 32-bit, which admittedly is a dwindling portion of the folks, but again, if we port to Raspberry Pi, it ain't dwindling. Potentially. But yeah, point being, it's less and less people, unless you're talking about, say, China. China runs a huge number of XP machines, and they're all 32-bit. So it depends who you're targeting. But the point is, if you rely on memory mapping, that means that your file is really only going to be able to be, a gigabyte or something or less. It can't really be very large because it's got to fit in the actual memory space of the machine. On a 64-bit machine, you have plenty of address space, so you can memory map the biggest file that you ever wanted, because of course it's just memory mapping the file. It's not loading the whole file, right? And so that's fine. And you always have plenty of address space on 64-bit. But the reason not to memory map is 32-bit, it doesn't work. Maybe someday everything will always be 64-bit and always be able to memory map in that way, and you could do that. Second reason not to memory map, you have no idea when the operating system will choose to pull that stuff in, or what the cost may be to doing that, right? So being able to, so if you think about how you'd have to do that, you have to have a background thread where the background thread is going to go poke the memory and then stall until the operating system gets it in there, right? That's like how that's going to be structured. That's just a lot more implicit than I want it to be. What I'd rather be is just be able to issue the operating system a stream of like, load this block, this block, this block, this block, this block, let me know when they come in, right? And that's just really nice and clean, and it's telling the OS what I actually want to do, rather than memory map files where it's just kind of implicit what I want it to do. And it also gives me control over what amount of memory is actually used to store stuff from the file, because Windows will then just start saving, if it's memory mapped that file, it will start randomly making decisions about what gets evicted. It might start using up memory I actually wanted for me and make that for the file and swap out something we cared about in Handmade Hero when I didn't need it to store that stuff, right? So we lose a lot of control. So I would really recommend against memory map files. I don't think they're a very good idea unless you have a really clear plan of what you think you want to do with them and why you think they're going to be good, right? Do the Molly Rocket artists ever interact with the asset packer, or is it automated somehow if they immediately want to preview how their art looks in game? So that's actually a separate thing. At Molly Rocket, it's a totally different code base, so it's a very different thing. But yes, in fact, one of the things I'm working on right now at work is making the turnaround, is doing some things that make turnaround even easier than it would otherwise be. I was taught to use exceptions because it does not convolute the code with the error checking code. So that's kind of a pretty wide open topic. I guess what I would say is I do not know, I literally do not know a single good programmer who thinks exceptions are a good idea. I literally do not know one. Because there's a lot of things, programming practices, that different programmers have different opinions on, and I can find a good programmer who has an opinion one way or a good programmer has it. I literally don't know of one. Now, maybe I'm just not thinking of the right, maybe there's someone who does, who I do think is a good programmer who's just never mentioned it to me, but literally I just don't know anyone. And so without going into too much detail, I guess what I would say is exceptions are, C++ exceptions are something you should just never use. And sometime on Handmade Hero, maybe we can go into why that's true. There's a lot of reasons, but they are categorically bad, and we can go into why at some stream when we have more time. We're already over time here. But suffice to say, if you just want a rule of thumb, never ever use them, ever, under any circumstances. They are never a good idea. Pseudonym 73. Just as a clarification, when I said memory map file, I meant as an alternative to fread, not as an alternative to streamed loading. Oh, okay. Yes. That's okay. I see what you're saying. So I guess I must have missed the part of the discussion. I'm not sure why that came up as a Q then. Was somebody talking about, because we don't even call fread anywhere, so I'm not sure. But yes, so pseudonym 73 is saying if you're going to load a whole file into memory, and yeah, that's true. If you're going to load a whole file into memory, then memory mapping kind of gives the operating system the knowledge of what you're doing with it, so it can sort of be more efficient, right? It can go, oh, okay, I understand that he wants to access this whole file. I can just say, here's a block of memory that's going to map that file to it, and at that point you can avoid having double copies and things like this. All right. Looks like we are done. So I will wrap it up for today. Let's go ahead and save. Okay. Okay. Oh, and we've created a new debugging target as well. So we'll go ahead and save that in our build directory along with Win32 Handmade. All right. Thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. Today we had a little bit of unexpected sound debugging, but I'm kind of glad that we took a look at that, and I think we made a good change there. And then we got our asset files writing out partially. We still have a little bit more work to do, so I think tomorrow what we'll do is we'll just kind of finish up with that. What we need to do now is we need to handle the actual asset part. In order to do that, what we want to do is we want to load in the bitmaps and the wave files that the assets correspond to, and then we want to kind of write them out as we go. And that'll be kind of interesting. You can sort of see how that's going to work. And then we will be done with writing out our asset file. And we can switch over to reading in the asset file, which won't be very difficult, but it will take us a little bit of time to do that because although we can do sort of a test pass on it pretty quickly, what I want to do is then take that opportunity to show you how to go do proper file I/O in Windows. Because if you remember correctly, the only file I/O that we actually have in our platform layer right now is called debug, because it's just the debug version. And I said I wanted to wait a little while before we showed how to implement it properly. So that's also something that we're going to do now, because I want to show you how to properly do overlapped I/O in Windows, because there's different ways you can do it, and I'd like to show you what I think is probably the cleanest way that you can do it in a game, and it makes things kind of easier on you, and it's very efficient through Windows as well. So that's what we'll be doing for the rest of the week, and I think it's a pretty good thing. I'd like to target, I think by the end of the week we'll probably be in pretty good shape, and we'll have our asset file working relatively cleanly. So I think we're in good shape, and I think that's pretty cool. So hopefully you'll join me for some more asset file programming. We will be doing it tomorrow, 5 p.m. Pacific Daylight Time, just like today, right here on Twitch. If, in the meantime, you would like to play around with the source code at home, please remember that anyone who pre-orders the game gets the source code every night. After I'm done with it, it gets uploaded, and you can download it from Sendal. You'll get a little link in your email. You can download it. So if that interests you, head over to handmadehero.org. You can do that. And also on handmadehero.org, you got these other options up here. We talked about the tweet bot on today's stream. It's a thing that allows you to know when it's going to be scheduled, so that's a good place to check out if you want to catch a stream live. We also have a forum site where you can go watch annotated episodes from the past, so you can kind of see, like, if you missed stuff, if you're new to the series, you can see the older episodes, what we've been doing. Every last piece of code that we wrote for this game is fully commented by me up there. And there's members of the community who have gone through and annotated it with time markers, which is kind of amazing that they've been doing that. It's really kind of a pretty big undertaking, and they've done an amazing job doing that. It's pretty awesome. So check that out. It's also got a forum site you can ask questions. It's got ports to Mac and Linux if you want to follow along on different platforms. There's just great stuff up there. Check it out. Members of the community have done some really awesome things. We also have a Patreon page if you want to support this video series. It's always very much appreciated. It's a place you can subscribe. And that's about it. So I guess that's enough Handmade Hero for today. I will see you guys tomorrow. Until then, have fun programming.